Okay, today we're starting a new chapter. It's chapter 5. This is 5.1, and we're going to discuss rational numbers. What rational numbers are, how we can write rational numbers, very basic introduction into fractions. Okay, so let's look at the definition. A rational number is a number that can be written as a quotient of two integers. Now, integers are negative, positive whole numbers. That's kind of what we've gone with. So a quotient, remember, it's just we have a fraction bar. We have a number or an integer on top and an integer on bottom. We call that a fraction, but it's actually a rational number. Okay, any number that can be written as a quotient of two integers or in fraction form is a rational number, as we will see later. In a terminating decimal, we need to know what terminating decimals are. You've heard this before, but we're going to discuss it. In a terminating decimal, the division ends because you obtain a final remainder of 0. So anytime the decimal ends or terminates, means you have a final remainder of 0. A repeating decimal, a digit or a block of digits in the quotient repeats without end. And that's when we have to do the repeating bar above the decimal. Okay, again, this is stuff you've done. The only thing we're going to do differently is add probably I don't know if we'll get to that today, but we'll end up adding variables to our fractions, which would be something new for you. So we want to look at this, looking at the numbers we should know, whole numbers. Now remember whole numbers, let's get a pen here. Whole numbers are numbers like 0, maybe if we can get a pen, 0, 5, 7, 121. Okay, whole numbers are 0 and up basically, and they're not decimals. There are no decimals in it. So 0, 1, 2, 3, all the way up to infinity as far as you can go, which you can keep going obviously with these numbers. So those are whole numbers. When we look at integers, we're talking also the negative whole numbers like -5, -121, -7,532. Obviously no decimals, but we're adding the negatives with the whole numbers. Now, the whole numbers here are integers. All of the whole numbers are considered integers also, but some of the integers are not considered whole numbers. And when we start looking at the negatives of the integers, these numbers are not considered whole numbers. They're only considered integers here, okay? Now, when we look at rational numbers, we're looking at numbers like 3/5, 4/7, 2/3. Anything that can be written as a fraction is a rational number. Also, if we think about it, a whole number like 5 can be written as a fraction 5/1. So any whole number, anything in this little circle here is an integer, and it's also a rational number because it can be written as a fraction. Okay, any integer is also a rational number. It can be written as a fraction. But some rational numbers are whole numbers, some rational numbers are integers, but there are some rational numbers that are just rational numbers. Okay, and that is just kind of an introduction to what that is today. We don't have to really know more than that, but rational numbers, any number can be written in fraction form, is a rational number. Okay, moving on. Oh, too far. Let's go back. Okay, show that the number is rational by writing it as a quotient of two integers. Okay, so how can we show that 37 is rational? By writing it as a fraction or a quotient of two integers. So how do I write 37 as a fraction? Just put it over 1. Isn't that the same as 37? Yes, it's equal to it. So 37 is a rational number because we can write it in this form. Okay, here we have -59. We just simply write it over 1. Okay, it is a rational number because we can write it in fraction form. Now here you may say this is in fraction form, but no, it's in mixed number form. We need to make it improper. We need to make it simply in fraction form. Okay, so that's 5 times 3 is 15 plus 4 is 19. We can write that as 19 over 5, and that is in fraction form, or that is a quotient of two integers. That is a rational number, definitely. A point 4. Well, remember the first number after the decimal, behind the decimal, is the tenths position. So we could say that's 4/10. Now we could write it just like that. Now, yes, we would reduce this, but here we're just showing it's rational. So 4/10, point 4 is rational because we can write it as 4/10. 0.97. Okay, we can simply, remember this is the hundredth spot. So that's 97 hundredths. We can simply write it as 97 over 100. And we show that it's rational by writing it as a fraction. Write the fraction or mixed number as a decimal. Okay, well, we know 2/5. If we know our FDEs, we know 2/5 should be 0.4. Okay, 2/5 is 0.4. If you didn't know that, you just simply divide. Number two, 5, 6. Let's say we don't know our FDEs and we're talking about 5, 6. Let's divide 6 into 5 here. Okay, 6 doesn't go into 5, so I'll put the decimal and I'll put a 0. 6 into 50 goes 8 times. That's 48. Okay, that's a remainder of 2. Bring the 0 down. 6 into 20 goes 3 times. That's 18. 2. We're going to get a repeating decimal. I have the same remainder twice here. It's going to be 0.83 with a 3 repeating. Negative. So if you don't know, just divide. Remember, top in, bottom out. It's 6 divided into 5. 3/10, well, that's 0.3. Okay. 1 and 9/20. Well, the 1 goes in front of the fraction. Okay. And I'm going to show you a different way. We could divide like this, 20 into 9. We could do that. Well, let's do that. Okay, some of us need help dividing. 20 doesn't go into 9. Let's put a 0 there. 20 into 90 goes 4 times. That's 80. Got to put our decimal there. That's going to be remainder 10. Bring down a 0. 20 into 100 goes 5 times. 0.45. So the 1 is in front of the decimal. Don't have to mess with that. 45 is behind the decimal, so it's 1.45. Okay, 29 over 80. Again, I'm going to do 80 into 29. That doesn't go. 80 into 290. Well, 80 goes into 24 3 times. 8 goes into 24 3 times. So we're going to try 3. It's going to be 240. That's going to be 50. That worked good. Bring down the 0. 8 goes into 50 6 times. Okay, there's a decimal there. That's 480. 20. 8 goes into 20 2 times. It's going to be 160. 40. Bring down the 0. 8 goes into 40 5 times, and that's going to be 400. So that's 0.3625. Okay, moving on. Write the decimal or as a fraction or mixed number. So 0.4 is simply 4/10, and we're going to reduce that. We're going to divide, and that's going to be 2/5. 0.324. I'm sorry, don't want to do that. It's going to be this is the thousandths place, so it's 324 over 1,000. Yes, we need to reduce if we can. I know 4 can go into this. Let's see what happens when we put 4 into 32 goes 8 times. 4 into 4 goes 1. That's going to be 81. Well, 4 into 1,000 is 250. Okay, so we have 81 over 250. 9, any number divisible by 3 goes into 81. Or 81 is divisible by 3 and 9, but 250 is not. So I think we're done here. Negative 2.73, well, that's just going to be negative 2, the whole number, then put 73 over 100. Okay, just make this the fraction. You've got the whole number there. Don't mess with anything else. This is going to be negative 1, and then the fraction part is going to be 24 over 1,000 because this is in the thousandths position. We can reduce that. 4 definitely goes into that. 4 goes into it 6 times. We can say, and we can keep going with that. That's going to be 6 over 250. We can still go with that. That's going to be negative 1 and 3 over. Okay, 250. That's going to be 125. And I think that works. Negative 1 and 3 1/25. Okay, 0.33 is 33 over 100. This is in the hundredths position. This is going to be negative 64 over 100. That can be reduced. But I'm kind of running out of time on my video, so I'm going to go ahead and go on. You should know how to reduce by now. This is going to be 3 7/10. That's in the tenths position. Okay, moving on. Write the repeating decimal as a fraction. Okay, I'm not going to show this on here just for time's sake, but what you want to do this is take the number that's repeating And with these, now this doesn't work for all of them, but the ones you'll see today, just count the number of places you have behind the decimal. And I've got 1. Put 1 9, that many nines below the number, and you've written the repeating decimal as a fraction. And again, for the ones you're doing today, that will work. I'm going to discuss this in class, but I've got to keep this video brief, and I've kind of already run a little bit over time. So 0.93, how many numbers are repeating? 2. Put 93 over the number of numbers that are repeating. Put that many nines. So there are 2 numbers repeating. Put it over 2 nines, and that's how you write the ones you will see today as a fraction. Okay, I'll discuss that more in class. Order numbers from least to greatest. The best thing to do would be to put them all in decimal form. This would be -1 1/4, which is -1.25. This is going to be -0.2, that's already in decimal form. 4.31 is already in decimal form. -3 is already in decimal form. 5 halves, that's going to be 2.5. 13 thirds, well, 3 goes into 13, 4, and it's going to be -4. And a third, which is -4.3 repeating. Okay, which one's the smallest? Well, looking at the negatives, this one is the smallest. Okay, the next smallest is this negative. Okay, the next smallest would be this negative. And then -0.2 is the next one. Then I've just got 2 numbers to look at, 2.5 and 4.31. This would be next. 4.31 is definitely the biggest, so this is 5. And this is 6. If we put them all in decimal form, they're pretty easy to order. Look at one more. Of the 20 students on the girls' swim team, 9 are seniors. Of the 24 students on the boys' swim team, 10 are seniors. On which team is the fraction of students who are seniors greater? Well, make fractions. 9 out of 20. And then I've got 10 out of 24. Okay, and to see which one's greater, we need a common denominator. Okay, and to get a common denominator, if you remember, we got 20 and we got 24. Upside down division. 2, that's 10 and that's 12. 2, that's going to be 5 and 6. I'm done. Multiply the L. I've got 10 times 12, that's 120. Okay, 120. 20 into 120 goes 6 times. 6 times 9 is going to be 54. 24. Okay, 24 into 120 goes 5 times. 5 times 10 is 50. Which fraction is greater? Well, 9 out of 20 is greater. And so we circle that one. And that is our lesson for today.